Okay, last chapter I told you that we were going through that chapter as a precursor to some of the concepts we'll need later. Well, this is one of those chapters as well. So we'll have to bear through this. Again, all of these concepts are very important in order to solve real-world problems that will happen in next chapter. Okay, so keep that in mind. Looking at this introduction, it says that earlier we learned about combining like terms. So we do have to review that concept by simplifying the following expressions. So we learned that when we combined like terms, they had the same variable with the same power. So we have 2x plus 5x. We learned that we add the coefficients, we keep the base, and then we add on anything else that did not have any combining. So that simplified down is 7x plus 3. That is not 10x because, again, that 3 does not have the variable x. Okay, same concept. It looks like we have two terms that have x squared. So let's go ahead and again add the coefficients. We get 8. We leave the base. 8x does not have anybody to add on to, so we are going to just say plus 8x and then plus the constant 7. That is as as simplified as possible, remembering that x squared and x are not like terms because their powers are different. Okay, moving on. Looking at x squared plus 3x plus 2. Does not look like we can do anything with that, so that is fully simplified. So we are just going to rewrite it and say that we're done. Okay, let's take that concept a step further by adding two polynomials together. Remember that poly means many and nomial means terms. So we're just taking many terms and we're adding them to many terms. Is this any different than what we did on 1, 2, and 3? Not really, except the fact that we are calling one a polynomial, another a polynomial. We have parentheses around them. All we're doing is we're still combining like terms. So what I see is I see a 2x squared and an x squared. That is a 1x squared. So I have 3x squared. I see a 6x and a negative 2x. So I see a positive 4x. And then I see a constant 7 and a constant 3. Whoops, which is, to someone who can do math, 10. So all I'm doing is combining like terms. Okay, so to say that, to add polynomials together, all we are doing is combining like terms. So combine like terms. Pretty nice, straightforward. Now let's look at this next one. We are subtracting polynomials. Okay, so let's look at this. We have a negative here, and we have parentheses. In algebra world, that means that that parenthesis is actually being distributed to all of these. I'm sorry, that negative is being distributed to all three pieces. What does negative mean? That technically means negative 1. So I'm going to rewrite that first term because he doesn't get touched. We have 3x squared minus 5x plus 2. Now we have the opposite of the second polynomial. We have a negative x squared. We have a negative 4x, and now we have a positive 6. Since we distributed that negative through, now we can go ahead and combine like terms. We have a 3x squared and a negative x squared, so we have a 2x squared. We have a negative 5x and a negative 4x, which is a negative 9x. We have a positive 2 and a positive 6, which is a positive 8. So not too much different than what we did earlier, but we do have to see that to subtract polynomials, we need to change the sign of all terms in second polynomial. Because isn't that what we did? We changed a positive to a negative to a negative, negative to a positive. You could say that we distributed, same thing. So we changed the sign of all terms in second polynomial. and then combine like terms. So those are the two rules that we are going to work with. Have we already done this before? Yes, so this actually will be a nice review. Just understanding that now we are actually adding and subtracting what are called polynomials, which means many terms. Okay, go ahead and get out the notes and vocab for this section. Okay, objective of this section is to add and subtract polynomials, which actually we already did in our intro, but there's many different vocab words that we do have to get used to here. A polynomial is a monomial or the sum of monomials, each called a term of the polynomial. We understand polynomial means many terms. Some polynomials have special names. Binomial is 2 terms, or 2 monomials. Trinomial is 3 terms, or what they call monomials. Understand that monomial is the same as a term. So here's monomial because there's 1 term. Binomial, because of that addition sign, we have 2 terms. Because of the subtraction and addition sign, that is now split up into 3 terms, or a trinomial. The degree of a monomial is the sum of the exponents of all of its variables. So when we look at this monomial right here, what is the sum of the exponents? Well, we have an x to the 1. So this is a degree 1 right here. This is a first degree. Okay, what about this one? This is a degree 2. Does he have a degree? He actually has a degree of 0 because he is a constant. What about him? He has a degree of, you're right, 3. Notice that we are just focusing on a term each. Here we have a degree of 1. Here we have a degree of 0. So that's how you find your degree. You look at that exponent. If we had x squared y to the 3rd, again, they said the sum of all of those. Because I had 2, I am going to say that this actually has a degree of 5. I am not adding each of the terms separately. That is 1 term, so that is a degree of 5. So now let's look at how that's different than a degree of a polynomial. Here we are comparing the whole thing. The degree of the polynomial is the greatest degree of any term in the polynomial. So greatest degree of him is the first degree. So we could look at this and realize right away this is a linear equation. We can look at this one right away and realize the highest degree is a 2. So this is going to be what's called a quadratic equation. Highest degree of this one is a 3. I understand there's a 1 in there, but that 3 trumps that 1. So this is going to be a cubic equation. Okay, so a lot of vocab in there that I will definitely say over and over in this section. But let's go ahead and look at example 1. It says determine whether each expression is a polynomial. If it is a polynomial, then we're supposed to find the degree and determine whether it's a monomial, a monomial, a binomial, or a trinomial. Okay, one of the only rules that we have to look at of whether it's a polynomial is that all degrees are positive. On variables. I'm looking at me not being able to spell up here, on variables. Really the only thing we have to look at, okay? Or remember how we said no variables in denominator? That's basically the biggest thing, no variables in denominator. Okay, with that really the only rule that tells us whether it's a polynomial or not, let's go for it. We have 4y minus 5xz. Is it a polynomial? Yes. Okay, there are no negative variables, so we are going to say a yes, okay, because it's a sum of 2 monomials. Now we have to look at what degree it is. Well, we have to look at each of these pieces separately. This y is the y to the 1st, so he's a degree of 1. Look at this. We have an x to the 1st and a z to the 1st here. Remember, we have to add those two. So this is a degree of 2. So what's the degree of the whole polynomial? 2. This is the 2nd degree. Okay. Now we have to look at what kind of polynomial it is. And remember, to find this, all we're doing is we're adding how many terms are there. There is one term, two term. So this is a binomial. That has nothing to do, just a sec, I have to be able to spell, talking right at the same time. This binomial has nothing to do with this degree. Degree deals with, again, the sum of all of the powers. The polynomial name deals with how many terms we have. Okay, so let's just look at negative 6.5. Is that a polynomial? Yes, it actually is, because again, the only thing that says no is that if we have a negative variable. Yes. Why? We could say it is a real number. Okay. Remember, going back to terms, terms can be numbers, variables, or the product of both. That is the same thing with polynomials. Okay. What degree is this? Remember, degrees deal with variables. There is no variable here, so we have a degree of 0. Constants have a 0 degree. Okay, what type of polynomial is it? How many terms do we have? We have 1. So this is called a monomial. Okay, degrees deal with the powers. Monomials deal with the terms. Okay, now let's look at C. Here is our problem. We cannot have a negative variable. So is this a polynomial? No. Okay, we are going to say there is a variable in denominator. Technically, denominator. Man, can I not spell and write at the same time? Because if we rewrote this, remember, negative exponents mean that I would drop that to the denominator. And there's our problem right there, that a to the third. So there is no degree. We can't even call it a polynomial, so we don't have to do those two. Okay, last one. Is this a polynomial? Yes, it is. Okay, first off, I noticed right away that I can actually combine those two terms, so I'm going to do that just to see if that changes things. It does a little bit, so that's 5x plus 3. Is it a polynomial? Passes the test, everything is positive. Yes. It's the sum of 3 monomials. What's the degree of this? Let's look for the highest degree. We have a degree of 0, degree of 1, degree of 3. So 3 trumps the other two. This is a degree of 3. But then what is this? Is this a monomial, binomial, or trinomial? We have 3 terms. 3 means tri. Okay, many different new vocab words. So go ahead and try that with this guided practice, making sure that it passed all of the tests, understanding the difference between the degree and then what type of polynomial it is. Okay, there we have it. 3 yeses and a no. Your explanations there, positive variable. A lot of times we're going to say that there are sums of different monomials. One of the trickiest ones, trying to find a degree on C. Remember, we are adding all of those powers together. So this is actually a third degree. It is a binomial though, because there are just 2 terms there. Okay, moving on. A couple more vocab words. The terms of a polynomial can be written in any order. However, polynomials in one variable are usually written in standard form. So let's look at what standard form of a polynomial means. It has the terms in the order of greatest to least degree. So we've kind of talked about that earlier, that I like to have that x squared before the x before the constant. Again, greatest degree down to descending order. That is different than a coefficient. In this form, the coefficient of the first term is called the leading coefficient. Remember, coefficient deals with that constant number. That is much different than a degree. So understand the difference between that. Okay, so example 2, we're supposed to write each polynomial in standard form. So greatest degree down, then identify the leading coefficient. So standard form, what has the highest degree? This one does. Who has the second highest? That first term, and then the third. So we are going to write this as 4x to the 5th. This is a positive 3x squared and a negative 7x. Okay, now we're supposed to identify that leading coefficient. Remember, that is the constant that is attached to that first one. So Whoops, that did not change my color. Leading coefficient then is 4. So I have them in standard form. I realize my leading coefficient is 4. Okay, going through these steps again, looking at that greatest degree. I'm going straight for that 4. Then I see a 3, I see a 1, and I see a none. So that negative is attached. Whoops, I'm sorry, this negative is attached. So negative 2y to the 4th minus 6y to the 3rd. This is a positive 5y, and we are subtracting a 9. Okay, what is my leading coefficient? It is the constant out front. So I'm going to say my leading coefficient is -2. Okay, vocab words, getting very used to these because we are going to see them a lot in next chapter. So go ahead and do this, or do guided practice 2. Okay, just remember greatest to least degree doesn't deal with coefficients. So don't look at this and say 8 is the biggest number, that goes first. We go straight for those degrees and then we go down from them. There. Then we look at that leading coefficient, the number out front. The lead dog is 4, lead dog is -7. Okay, now we're getting into the adding and subtracting polynomials that we should be pros with. We decided that when we add polynomials, really all we're doing is combining like terms. But then also knowing that now we understand we have to write these in standard form. Okay, so it does say horizontal and vertical. We're going to go ahead and do vertical form here, and then we'll do horizontal on this one to show you the two different types. So again, combining like terms, I see 2x squared here. I'm going to combine my x's, and I'm going to combine my constants. Okay, so I have a -2x squared. Notice I went straight for the highest degree because I know he's supposed to be first anyway. Then I have my x's, which is 11x. Then I have my constants, which will be -4. Okay, that is called horizontal. Now we're going to look at the vertical form. On this one, what we do is we go ahead and we set them up. I'm going to actually work with this longer one first because it has all of the terms. I'm going to write it in descending order. So I have 2y to the 3rd. I have a positive 4y squared. I have a -4y. And then I have a positive 8. Then I'm going to line up the second one underneath the same terms, the like terms. So I have a 3y here. I have a y to the 3rd here. And I have a -5 here. Sometimes this helps with kids that really like to be organized because now we're just adding straight down. Kind of like when we did elimination with solving systems of equations. I have 3y to the 3rd right here. I'm going to do this in a different color. That color is kind of hard to see. 3y to the 3rd. I'm not adding anything to my 4y squared. I have a -y here, and I have a positive 3. So depending on which way you want to work this. Okay, sometimes this vertical form is really nice because we can see the organization. A little bit harder to see that when we're just combining like terms over there. Okay, so either way you want to solve or simplify finding the sum of guided practice 3, go for it. Okay, looking at the horizontal form, again, I just combined like terms. Vertical form, again, sometimes is a little bit harder to set up because we do have gaps every now and then, but once we have it organized, we can add it straight down. Realizing again, if I had a -2, I am technically adding 1 there, so that is a -y to the 4th. So understanding there is an understood 1 there, but then when we do simplify it, we don't put that understood 1 in there when we do simplify. Okay. Knowing how to subtract polynomials. Remember, we add what's called by adding it's additive inverse. So we change the signs of everything in that second term. Okay, so again, how do we want to do this? Let's go ahead. I'm going to rewrite this first one in correct order. So I'm going to say 2x squared minus 2x plus 3. Then I'm going to change the signs of everything in here. I know that this second one is a -3x squared, a 4x, and a positive 5. Okay, then we can go ahead and just add them straight down. This ends up with a negative x squared. Here's a negative 6x, and here is a positive 8. Okay, so one way to do it. Notice I did do a couple steps together, so if you would rather write out that step, totally fine, which is what we're actually going to do on this one. I'm going to write out 7p plus 4p to the third minus 8. Then I'm going to tell myself that technically that negative is being distributed through to all of those. So I end up with a negative 3p squared, a negative 2, and a positive 9p. Then I combine like terms. Looks like I have a 4p to the third all by itself, and a negative 3p squared, and then it looks like I do finally have two terms that I can combine together, so I have a positive 16p, and then my constants I can combine together as a negative 10. So pretty simple concepts, but again, you do have to slow down and make sure you get the right degrees there, that it is written in standard form, that we are adding those numbers correctly together. Okay, two different types of concepts. Go ahead and use the one you like the best to find the difference of guided practice 4. Okay, two different strategies, getting the same answer for both of them. Understanding again that we are basically adding the opposite of that second polynomial. Okay, real world example. Again, these type of concepts we're not going to see very much until we get to things like this with businesses. Realizing that when we get equations like this, they have a lot of times programs or algorithms that they use to set these up. Then the real world concept comes where we're going to quickly combine these together in order to find out some information. So with that in mind, we have the equations P equals 7m plus 137 and C equals 4m plus 78 represent the number of cell phones P and digital cameras C sold in M months at an electronics store. We're supposed to write an equation for the total monthly sales T of phones and cameras. Then predict the number of phones and cameras sold in 10 months. Okay, so again, we are supposed to write an equation for the total monthly sales of phones and cameras. So we want our total sales to equal our phones and our cameras. Okay, so together. So I'm going to put a plus here. I'm going to go back up here. P deals with cell phones. So I understand this piece is 7m plus 137. I'm adding that to my cameras, which is 4m plus 78. And I know that that is my total monthly sale. I don't know m, but I can still combine like terms. Looks like I have 11m plus 137 plus 78. Okay, so our total monthly sales are 11 per month plus 215. Okay, then we're supposed to predict the number of phones and cameras sold in 10 months. So we're pretty good at that. We're going to plug that 10 in for our months, add 215, and we end up with 325. So total monthly sales in 10 months is 325. Cell phones and digital cameras together. Phones and cameras. Okay. So again, sometimes a hard concept when all of a sudden we start seeing variables and problems like this, but understanding that they do have a pretty elite type of program that they use in order to set those up, kind of like what we did with our scatter plots. And then we use those type of equations to plug in and predict how many phones and cameras we're going to sell. Okay, so with that in mind, try guided practice 5. Okay, here we are looking at the difference in monthly sales between phones and digital cameras. So we are subtracting the two, knowing that means that we distribute a negative through. So the difference is 3 per month plus the 59 that we started with. After 24 months, we plug that 24 in. We notice that we have a difference of 131. So In a nutshell, there is a lot of vocab that deals with standard forms, different kinds of polynomials, different degrees. We need to get comfortable with those so we can go smoothly through next chapter. So do focus on that in the assignment for this section.